Hey guys, welcome back to another video. In this video, we're going to be solving some of the hard questions from P1, which is Pure Mathematics 1. So I've sorted the questions randomly. These are not based on their topics. So let's start off with question 1. Right. So question 1 is from functions. So the question is, the function f is defined by f of x is equals to x squared minus 4x plus 7 for x is greater than 2. Great. Now, they're giving you the domain, right? They've given you the domain, the range of x. What is the first question? Express f of x in the form x minus a whole square plus b. You basically have the complete square. You have to do completing square and express this equation in this form. How do you do that? Very simple. You take x, put it over here. You take the half of the middle value, which is minus 4x. What is half of 4? 2. You put it over here. And then you subtract the whole square of this value. The whole square of the value over here, which is 2. So you have to do minus 2 whole square. Right. Make sure you put a bracket over here. In this case, even if you don't, it's not going to be a problem because often why you need to put the bracket is, let's say you had 2x squared minus 4x plus 7. In this case, you have to take 2 common over here, x squared minus 2x plus 7, and then proceed with your completing square, right? So in this case, the second bracket matters. Alright, but in this case, even if you don't put the bracket, no problem. The point is x minus whole square minus 2 square plus 7, right? Okay, so if we take off the brackets, and it's going to be minus 4 plus 7. Your final answer is x minus 2 whole square plus 3. This is after you complete the square. Great. What is the question? And state the range of f. So over here, this is a maximum or minimum curve. This is a minimum curve since it's a positive in front of x squared. Therefore, it's going to be something like this, right? Okay. So over here, what is the turning point? How do you figure out the turning point from this equation? Very simple. This is your turning point on the graph. Now, what are the coordinates of this point? So, where is the curve minimum? Let's figure that out. Where is the curve minimum? At what value of x is the curve minimum? It has to be x is equals to 2. Why? Because when x is equals to 2, this entire value becomes 0. 0 plus 3 is 3. Can you get any value lower than 3? Let's see. If, let's say, x was over here, minus 2. Minus 2 minus 2, minus 4. Minus 4 whole square is 16. So it increases. Whatever your x value is, your y output is going to increase. Why? Because you have a square. Therefore, any negative value of x or positive value of x is going to give you a positive value from this, right? So in that case, we know the minimum value is only received when x is equals to x is equals to positive 2. Why? Because only in that case, this entire thing is going to give you 0. Therefore, if we proceed with that, the turning point is going to be x is equals to 0. X is equals to 2 and y is equals to 3. Because when this is 0, this is your minimum y value. That is your minimum y value. When x is equals to 2, your y value is 3. Okay, that is your minimum point. The other way to do this is obviously dy by dx differentiating, but this is at times often easier. Okay, So the range is going to be, since 3 is your minimum value, right? The least possible value, your range is going to be greater than 3. Now, one thing to remember over here is, guys, you cannot give greater than equals to 3. A lot of people might make this mistake of giving greater than equals to 3. Why can you not give greater than equals to 3? The point is, look over here. They've given x is greater than 2. So you cannot take 2 as your x coordinate. Where? Yeah, over here. You cannot take 2. You have to take something that is slightly larger than 2 at least. For the lowest value, let's say 2.00001. That is greater than 2. Therefore, if you do take a value, an x value that is slightly greater than 2, in that case, your range is obviously going to be slightly greater than 3 always. Since you're not taking 2 as your x coordinate ever, your y coordinate, your minimum y coordinate is obviously going to be at least slightly greater than 3. Since you're starting with x is greater than 2 and not equals to, that's why your final range is also going to be greater than 3. Alright, so that's the easy part. Next, what do we have for question 2? Obtain an expression for f inverse of x and state the domain of f inverse. So you already expressed it as x minus 2 whole square plus 3. From this, going to the inverse function is easy. And even if you don't have your equation in this form, I highly suggest, if the question asks you to express anything as an inverse, you have to take this, take the expression and express it in this form, a plus b whole square form. Right? So, I mean x minus a whole square plus b form. So, the point is, when you do this, you can easily make your x the subject and get the inverse function. But when you have a quadratic equation like this, it's very difficult to make x the subject and get the inverse function. Which is why we always do completing square to get the inverse function. Okay, great. So how do we proceed? Y is equal to x minus 2 whole square plus 3. Now you're going to take 3 to the other side. Taken. Now, if you take off the square, is going to be root on this side, root over here and root over here, which is going to give you x minus 2, taking it over here, and root plus minus root of y minus 3. Y plus minus, whenever you take a root, you have to add a plus minus in front of the root sign. Okay. Now what do you do? You have a value of expression for x, which is 2. If you take it to the other side, 2 plus minus y minus 3, root over y minus 3. Now, what do you do over here? Do you take the positive side or the negative side? Here's the thing. If you look at the domain that they gave for f of x, remember, the domain of f of x is greater than 2, right? Now, what you should already know is the domain of your function. The domain of your function is going to become the range of your inverse function. Okay? So, if x is greater than 2 is your domain for your normal function, y is going to be greater than 2 for your inverse function. Your range is going to be greater than 2 for your inverse function. That is your range. You should already know this, right? So if you do know that, you cannot have the minus sign over here. Why? Because 2 minus any value is going to give you an ultimate y value that is less than 2. That is less than 2. So you cannot have a minus sign. What you can have though is 2 plus root over x minus 3. Why? Because this is going to give you a value, a range that is greater than 2. That is greater than 2. So this is why you take only the positive sign. You do not keep your answer as plus and minus. You keep it as either a plus or minus. At least when you have a range given, you have to calculate accordingly and figure out, is positive going to satisfy my range or is the negative going to satisfy my range? So you have to figure that out and keep it in mind. Okay, that is your question 2. The function g is defined by g of x is x minus 2 for x is greater than 2. Okay, so x is greater than 2 is your domain. The function h is such that f is equals to h of g and the domain of h is greater than 0. So for h, the domain of x is greater than 0, fair enough. And since h is a function of g, h of g, in that case, x has to be greater than 2. Why? Because g is a function that is inside of h. So you have to satisfy the domain of g. But most likely you don't need to know this for this question. What they're asking though is obtain an expression for h of x. How do you do that? So let's try to put it in this equation first, right? F is equals to h of g. Okay, what do you know about f? You know f is equals to x minus 2 whole square plus 3. Plug that in over here. What do you have left? You have h of g of x. You have h of g of x. Next, what do you do? Do you know g of x? Yes, you do. You know g of x is x minus 2. Plug that in over here. X minus 2. Now, the question is, how do you find h over here? How do you find the expression for h over here? The point is, since h is a function of x minus 2, you have to figure out an expression for h where if you plug in x minus 2, this is the exact expression that you get. This is the exact expression that you get. Find an expression of h where if you plug in g of x, you get f of x. Because they're telling you f of x is equals to h of g of x, right? So how do we figure out what the answer is going to be? See, if you look at this side, they've kept it pretty simple for us to understand. So if you look at the left hand side, you can see if you consider this as g, can you consider that as g? Yes, you can, because g is x minus 2. G is x minus 2. So consider this g of x. G of x whole square plus 3. So you already have an answer. Because if you consider this as x square plus 3 is your function of h. X square plus 3 is your function for h. How do you know that? Let's see. If you plug in x minus 2 over here, which is x minus 2 whole square plus 3, that is going to give you this exact f of x function. So again, if we backtrack and try to figure it out, the thing we're doing is, you know, h of g of x is a function that is exactly identical to f of x. So you simply try to make a function that if you plug in g of x, you're going to get f of x. How do you do that? You use the f of x function and consider this entire expression as g of x whole square plus 3. Now you already have the answer. G of x is going to be your x, where x minus 2 will be plugged in, x squared plus 3, and this is going to be your answer, your h function. So we basically are going in reverse and trying to find the function of h. Now, a lot of you could have tried to make h the subject over here, but that wouldn't work out. Why? Because this is actually defining h as a function of g of x. So you cannot make h the subject over here, right? So from this, we get h is equals to x squared plus 3. If you're still confused, you can plug in x minus 2, which is the function of g, and you will get the exact expression identical to f of x. So that's how you solve this. Great. Is that it? To range. Right. That is your question 1. Next, we can move on to question 2. This is, I guess, for circle theorem or coordinate geometry. I guess both. Okay. So for this question 2, it is from what? May, June 21, variant 1-3. Okay. So for this question, what do? Points A, which is minus 2 and 3. Point B, which is 3 and 0. Point C, which is 6 and 5. Lie on the circumference of a circle with center D. Okay. Center is D. Show that angle ABC is 90 degrees. ABC, which is ABC, right? This angle has to be 90 degrees. You should already know from before that if you have a circle and if you have a triangle that has one of its side going through or being the diameter of the circle, your triangle will be a right angle triangle. If one side of your triangle in the circle is the diameter, your angle in between is going to be 90 degrees. Okay? So, how do we find out? That if it is actually a right angle triangle? The best way, the easiest way to do this is if AB and BC is perpendicular to each other, then indeed the angle in between is 90 degrees. So they want to know the proof of ABC is 90 degrees. The simplest way to do it is the product of each of their gradient should give you minus 1. If they do give the product as minus 1, you have already proven that they are perpendicular to each other, meaning the angle in between is 90 degrees. Okay. So we find out the product of the gradient of AB and BC. Okay, what is the gradient of AB? 3 by minus 5. What is the gradient of CB? 5 minus 0 by 6 minus 3, which is 5 by 3. Okay, find the product of both of these gradient. 3 by minus 5 times 5 by 3 is going to give you minus 1. So, you know that the product of their gradient is minus 1. Therefore, they're perpendicular to each other, meaning the angle in between is 90 degrees. That is exactly what they wanted to know. Fair enough. Moving on to the next question. Hence, state the coordinates of D. They want to know the coordinate of the center. Simple. So you already know that ABC is a right angle triangle. Therefore, AC definitely is the diameter, because you will never get a right angle triangle inside the circle without having one of its side as the diameter. You cannot have that, right? So in that case, we know AC is the diameter. AC is the diameter. If AC is the diameter, in that case, the midpoint of AC, since AC is the diameter, the midpoint of AC is going to be your center. So simply go off to finding out the midpoint of AC, which is going to be minus 2 plus 6 divided by 2. And 3 plus 5 divided by 2, which is going to give you a coordinate of 2, 4. Okay, that is your coordinate for the center. Fine. Next, what do? Find an equation of the circle. Okay, so you know the center, and you will have to find out the radius, right? You can find out the radius easily, no problem. Okay, so for the radius, what do? Just find out the length dB, dA, or dC. Either will work because both of those, all of those are the radius of the circle, right? So let's find out for any, which is, let's say, the center and B. Okay, let's find out for dB. How do you find out the radius? How do you find out the length? Simple equation. Okay, so for this one is x, let's say 2 minus 3 whole square plus y, what is y? 4 minus 0 whole square is r square. You actually need r square over here. R square. So we'll keep r as it is. We're not going to take the root. So in this case, what's going to be the answer? Which is 16. So r square is actually 17 as shown over here. So you get the radius, radius squared. And you know the center of the circle. So x minus the center of the circle, which is 2. Y minus the center of the circle, which is 4. And add them and put a square above them. And that is your circle equation. This is your r square, right? So that is your equation of circle. Very simple. I wrote this in one line. You're not supposed to write in one line. You're supposed to show the step for at least the radius. That is one of your mark as well. And this entire expression is one of your mark. Okay, great. Moving on to the real part. I mean, the interesting part. What do you do over here? What is the question? The point E lies on the circumference of the circle such that BE is the diameter. Great. So, BE is aligned such that it is the diameter of the circle, meaning it goes through the center of the circle. Interesting. Find the equation of tangent to the circle at E. Fair enough. So, you know a coordinate B. Great. You know the coordinate D, which is the center of the circle. Now you have to find out what is E. You should already know that if you connect B and E, it's going to give you the diameter of the circle. It's going to give you the diameter of the circle. If you know that, you should know that E is directly opposite to B. It is directly opposite to B. If I draw the circle differently and put D over here and E over here and B over here, isn't E exactly opposite to B? Yes, it is. Therefore, this distance and this distance is exactly the same. So if E and B is the diameter, the point D is the exact center of E and B. So D is actually the midpoint of BE. D is the midpoint of BE because wherever you put the B, let's say over here and over here, D is always going to be the midpoint because E and B is the diameter, right? So the diameter always goes through the center of the circle. So this distance and this distance is definitely equal. If you know that, you can use the midpoint equation. I don't know why I did this, but yeah, you can use the midpoint equation to find out the points of E. Let's consider the coordinates of E as x and y for the ease of understanding. So x, which is the x coordinate of E, plus the x coordinate of B, which is 3, divided by 2 is going to give you 2, right? Because you already know the x coordinate of this center. So from this, if you make x the subject, you're going to get x is equals to 1. Same thing for y. Y plus 0 divided by 2. Y plus 0 divided by 2 is going to give you what? 4. 4. Make y the subject and you're going to get y is equals to 8. That is your coordinate for E. That is your coordinate for E. So if you know the coordinates of E, what else do you need to find out? The equation of the tangent. The equation of the tangent. Okay, how do you do that? So basically, if I draw a few circles over here, I'll give you two examples. Let's say E is over here, B is over here. Again, E, this is the center, D, and E is over here, and B is over here. In these following cases, if I draw the tangent over here, and I draw another tangent over here, try to notice something similar. No matter where I put E and B, they are, for one thing, directly opposite to each other. The other thing notice is if I draw the line diameter from E to B, this is always perpendicular. The line EB is always going to give you a perpendicular, both of them are always going to be perpendicular to each other. The angle in between is always going to be 90 degrees. This line, tangent, and your diameter is always perpendicular. So that's the interesting part over here. If the line and your diameter is always perpendicular to each other, in that case, the product of their gradient is going to be -1. So you can use that theorem again, the gradient, the product of the gradient, and you can find out the gradient of the tangent. What do you know? You know both of them are perpendicular. You know the gradient of BD, which you can figure out. So you basically find out the gradient of BD, which is going to be, 4 minus 0 by 2 minus 3, which is going to be -4. That is your gradient for BD, this line. So what is your gradient for the tangent going to be? The negative reciprocal. The negative reciprocal is going to be +1 by 4, which is your gradient of the tangent. Since both of them are actually perpendicular to each other. Great. So you know the gradient of the tangent, which is 1 by 4, the negative reciprocal of the gradient that is perpendicular to itself, which is BD. So the gradient of BD was what? -4. So the gradient of tangent is 1 by 4. Nice. So now you know the gradient and you know the point E. So you don't need anything else to find out the equation for the tangent line, which is going to be, in this case, y minus 8, which is the coordinate of E, y minus 8. 1 by 4 is your gradient, x minus 1 is your coordinate of E. This is your, if you make y the subject, this is your equation for the tangent. Fairly simple. Okay. Great. That is your question 2. Alright, question 3. The point A has coordinates 1, 5 and the line L has gradient -2 by 3 and passes through A. Circle has center 5, 11 and radius √52. So first of all, a point A has coordinate 1 by 5. This is your A and this is a point. Okay. And the line has a gradient -2 by 3. But this line also passes through the coordinate A of 1 and 5, which is 1 and 5. Great. So the line is passing through A and has a gradient -2 by 3. Okay. There is also another circle which has center 5, 11 and has radius √52. What is the question? Show that L is the tangent to the circle at A. So they're telling you that L is a line such that, for one thing, it passes through A and it is also a tangent to the circle at A. Okay. So the question is, how do you prove it, right? How do you prove that the line is a tangent to the circle at A? How do you prove that? So basically, you know two coordinates, you know A and C, this, and if AC is, if A is indeed tangent to the circle, in that case, AC is obviously going to be perpendicular to the line. It has to be perpendicular to the line. Because whenever you have a circle, let's say with center C, and you have a tangent, the angle between the radius and the tangent is always 90 degrees. So both of them are always perpendicular. Therefore, even in this case, if A is the point where the circle is tangent to the line, in that case, the angle between CA and the line is obviously going to be 90 degrees. Okay, so if you know that, what you can do is again use the gradient product rule. And for that, you need to find out the gradient of AC, which is going to be 11 minus 5, and 5 minus 1. You do that, and you're going to get a gradient of 3 by 2. You already know the gradient of the line, which is minus 2 by 3. If you multiply both, you're going to get minus 1. So this is your product of both the gradients, which is minus 1. Hence, you have already proven that both of them are perpendicular, which is one of the condition 1, perp, meaning perpendicular. Both of them have to be perpendicular. Now, the other thing is, you might ask me that what if A is the circle is over here and the line is over here, and they're not touching, but this C and A, or whatever it is, X, and this A, both these line, M of line and M of Cx might be perpendicular. Both the gradients might be perpendicular to each other. It might happen, but they're not tangent to each other. So how do you prove that both of them are tangent and perpendicular? Meaning, how do you prove that the line is touching the circle and it is a tangent? How do you prove that? So if I was in your place, I wouldn't leave my answer just at this, although most likely in the masking they just wanted to see this. But what I would do to prove that it is indeed a tangent and is touching the surface of the circle, what I would do is I would plug in the coordinates of A, which is where? Yeah, this 1 and 5. I will plug in the value of X, let's say, in the circle equation. I would write the circle equation, which is X minus 5 whole square plus Y minus 11 whole square is equals to 52. Since root 52 is your radius, 52 is your R square. So in this equation, what I would do is I would plug in the X coordinate 1, let's say, for A, and I would see and test if my Y coordinate is 5. If my Y coordinate is 5, in that case, A does lie on the circumference of the circle. And in that case, you have entirely proven that, for one thing, the line is actually touching the surface of the circle, and the gradient of CA and the line is perpendicular. Okay, so in the bar scheme, they've already only shown this part, so you can leave it at that. But if I were you, I would go up and show the equation as well for the circle and plug in the values of the coordinate A, right? So yeah, moving on to question B. Find the equation of the other circle of radius root 52 for which L is also the tangent at A. Okay, so what they're telling you is there is another circle with the same radius of the same size, and it is directly opposite, or I mean, at least touching the line L at the same point A. So there is another circle, this one, which is tangent to line L as well, but at the exact same coordinate A. So therefore, it has to be a reflection of this circle, our initial circle, right? Let's call this circle X and let's call this circle Y, right? So circle Y is the direct reflection of circle X. How do you know that? Because it's opposite to each other and it is touching the same exact point A, has the same radius and is directly opposite to each other. Okay, so I mean that doesn't really matter if it's a reflection. The point is the distance between CA and AD. Let's say that the center for this circle is D and the center for this circle is C. In that case, since the radius of both is equal and is touching the same point A, in this case the radius is root 52. Even in this case, your radius is root 52, right? So if that is the case, 52, CD is a straight line. In that case, CD is a straight line and A is equidistant from both C and D. A is such that it is equidistant from C and D. Therefore, the length CA and AD is equal, the radius. In that case, you can find the coordinate of the center Y in our case using the midpoint theorem. Okay, so they want to know the equation. Yeah, they want to know the equation of the other circle, which is circle Y. So in that case, first of all, you need to find out the coordinates of the center D. Okay, you already know the radius, so you don't need to worry about that. Simply find out the center coordinate. Okay, in that case, what you do, you find the midpoint of C and D, which is 1, 5. So for X, let's say 5 is your X coordinate for C, and X is your X coordinate for circle D, and divide by 2 is going to give you 1, which is the midpoint A. Okay, moving on to the Y, 11 plus Y divided by 2 is equals to 5, which is the coordinate for K. Okay, so that is your coordinate for the center D for circle Y, this circle. So you already know the coordinates of the center, which is x is equals to -3 and y is equals to -1. You just have to make x and y the substitute over here. So if you do that, now you have the coordinates -3 and -1. Just plug it in the circle equation, which is x minus -3 whole square plus y minus -1 whole square is equals to square of the radius, which is simply 52. Okay, so now you have x plus 3 whole square plus y plus 1 whole square is 52. That is your circle equation and you have your answer. Okay, so that is question 3. Fairly simple. Let's move on to question 4. Okay, what does question 4 tell you? This is from Asian 21 variant 1-2. Okay, well, the equation of a curve is y is equals to x minus 3 times root over x plus 1 plus 3. Okay, the following points lie on the curve. Non-exact values are rounded to 4 decimal places. Okay, find k, giving your answer correct to 4 decimal place. What is k? K is in the equation, I guess. Oh, no, it's the coordinate. Okay, so the coordinate of A is 2 and k. So if A does lie on this curve, very simple. A is the coordinate of the curve. So you just plug in the x coordinate the x coordinate, and you should be getting the k, value of k, or the y coordinate. So just plug in the value 2, which is 2 minus 3, 2 plus 1 plus 3, and you should be getting k is equals to 1.2679. Make sure it's 4 decimal places. Okay, so your answer should be k is equals to 1.2679. Okay, fairly simple. Question B, find the gradient of AE, giving your answer correct to 4 decimal places. Find the gradient of AE. Okay, you know the coordinates of A, you know the coordinates of A, you know the coordinates of E. Yeah, you know the coordinates of E. So find out the gradient, very simple. 3 minus k, which is 1.2679, divided by 3 minus 2, which is basically 1.2679. So whatever this is, it's going to be your gradient, 1.7321. That is your gradient for AE. Very simple. Okay, question C. The gradients of B, E, C, E, and D is rounded to 4 decimal places, and they are, for BE the gradient is this, for C the gradient is this, DE the gradient is this. State, giving a reason for your answer, what the value of the 4 gradients suggest about the gradient of the curve at point E. The gradient, okay, so there's a curve, you don't know the shape of the curve, right? Because this is a pretty different and unique sort of curve, right? So it's not a direct quadratic curve. Okay, so you don't know the shape of the curve, but you can predict the gradient of the curve from the given information. They've given you that the gradient from B to E is 1.97 whatever. The gradient from C to E is again 1.9975, right? And again, the gradient from D to E is 1.9997. What is the common trend over here? The closer you're getting to E, and the more exact your change in value is, or the shorter your change in value is, meaning if you, let's say this is your curve and you're finding out the gradient at that point, the most accurate way to get the gradient at, let's say, this point is to find the shortest change in y by change in x. That is going to give your gradient. So for, let's say, this is B and this is your what is that, E, and this is C and this is D. So if you find the gradient of B to E and then find the gradient of C to E and then find the gradient of D to E, the closer you get to E, the more accurate your gradient is going to be. Therefore, if the common trend is the gradient is approaching 2, that means 2 is your gradient at E. Because the closer you get to E, the shorter your change in y by change in x gets. It's approaching the value 2. In that case, the gradient at E might be 2. That is the most accurate assumption. Okay, mind it, it's an assumption because you don't know the right values, right? The equation, you can't differentiate the equation and find out the gradient at that point. So this is an assumption according to the trend. Okay, if you want to make sure that the gradient at that point is indeed this, you can use your calculator, differentiate this and plug in the x value to get it. Anyways, so how do you answer this? The gradient at E is 2 because the gradients B, E, C, and D are approaching the value 2. Very simple. Okay. Yeah. So that is question 4. Question 5. What is it saying? Functions f, g, and h are defined as follows. F of x is x minus 4, x to the power half plus 1. For x is greater than equals to 0, g of x is mx squared plus n. For x is greater than equals to minus 2, where m and n are constants. H of x is x to the power half minus 2 for x is greater than equals to 0. Okay. Solve the equation f of x is 0, giving your solution in the form x is equals to a plus b root c, where a, b, and c are integers. Okay. So, you know the equation f of x. Now, whenever we have a situation like this, what we do is we substitute a common value, a common expression. What is common in both of these variables? I mean, both are x, but what else is common? How can we factorize it in a way to take the common value out and substitute as another constant? What could that be? Okay, let's figure it out. You know, x to the power of half is one of your expression, is one of your variable. The other is x, right? So if I write x to the power half times 2, is it giving you a common power of half? Yes, it is. It's giving you a common power half. And you already have x to the power half. So why not express x as x to the power half times 2? And you already have x to the power half over here. And substitute x to the power half as k. In this case, what you're going to be having is x to the power half times 2 minus 4 x to the power half plus 1. So what you can do is just substitute this so that later on you can solve for x. Later on you can solve for x using square over here. Okay, so you can substitute x to the power of half using any constant, whichever you prefer, and the answer, the expression is going to be k squared minus 4k plus 1. So we are substituting just the x to the power half part. Great. So now you have a quadratic equation that you're used to and you can solve it. So k is equals to 2 plus 3 and k is equals to 2 minus 3 minus 3. So these are both your expression for x to the power half. So let's introduce that. X to the power half is 2 plus root 3. X to the power half is 2 minus root 3. Okay, so if that is the case, how do we solve for x? You plug in a power of 2. So take 2, take 2, take 2, take 2. Very simple. And you have x over here, and the you follow a plus b whole square formula. So 4 plus 2 root 3 plus 3. That is your expression after using the formula. Right, so for this again, 4 minus 2 root 3 plus 3. Okay, so that is your expression for x. Now, if you simplify, 4 plus 3 is 7. Again, 4 plus 3 is 7. One is 7 plus 4 root 3. The other is 7 minus 4 root 3. What did I write? 7 minus 4 root 3. Sorry. Yeah. So, there are two answers. 7 plus 4 root 3 and 7 minus 4. So, these are both your roots of the equation. Okay. So, that is your A. Fairly simple. Now, what is part B telling us? Part B is telling us, given that f of x is g of h of x, a composite function, find the values of m and n. Okay. So, in this case, what's happening is the function f of x is exactly identical to g of h of x. So,
your first job is to find out g of h of x. What is your g of x function? Your g of x function is mx squared plus n. mx squared plus n. So mx squared plus n. So how do you find g of h of x? You know h of x is what? X to the power half minus 2. So plug in x to the power half minus 2 where x is, right? So you have m times x to the power half minus 2 whole square plus, that is your g of h of x function. Alright, fair enough. So what do you do next? Now you have this identical, is supposed to be 3 lines. Okay, so this is identical to this. Fair enough. So if you remember identities, you're going to use that in logic and you're going to equate the coefficients to find out the values of m and n. Fair enough. So in that case, what do? You basically square this expression and you're going to open the bracket and have this. So how do you square the expression? X to the power half is going to be square and it's going to be x. 2ab, which is 2 times x to the power half times 2, which is 4x to the power half, plus 4, which is 2 squared. So this is your expression after squaring the x to the power half minus 2. Okay, so now you can open the bracket and you're going to have mx minus 4 mx to the power half plus 4m plus n. So what you're going to do next is you're going to equate the coefficient for x. You're going to equate the coefficient for x to the power half and you're going to equate the constant. Okay, so for x you have, why did I put minus over here? Anyway, so the coefficient for x is 1. The coefficient for x over here is 1 as well. So m is equals to 1. I mean the coefficient of x is 1m. So on this side you have 1m. On this side you have 1. So your m value is 1. So m is equals to 1. You already know that. And to find out n, what you can do is the constant over here is plus 1 and the constant over here is 4m plus n. So what you do is you know the value of n, you know the value of m, right? So plug in that value, which is 1 is equals to 4 plus n is minus 3. N is minus 3. So that is your answer for m and n. Great.